So yesterday, or in the last lesson, we looked at trig on the Cartesian plane and where a terminal arm of an angle would finish if we were working on a Cartesian plane. And I've just written your cast diagram here again. Remember, this diagram shows me where the angles are positive. So in the first quadrant here's 0 degrees. In the first quadrant, all the trig ratios are positive. In the second quadrant, only sine is positive. Cos and tan would be a negative ratio. In the third quadrant, tan is positive, which means then that sine and cos are negative. And in the fourth quadrant, cos is positive, which then means that sine and tan are negative. We also looked at defining our trig ratio in terms of our x, y, and r. X and y are your x and y coordinates on your Cartesian plane. And r is for the radius of the circle that you'd make if you went all the way around in this green dotted circle here. So sine was y over r, cos theta was x over r, and tan was y over x. So we move from SOHCAHTOA, which you still need to remember for right angle triangles, to these x, y, and r ratios here. Okay, and then I also gave you a mnemonic yesterday. Save your rear. So sine is y over r. Cos x raised, so cos is x over r. Tan your exterior, so tan is y over x, just to help you remember those. All right, so when you look at the lower Cartesian plane here, remember this is x and this is y. If you wanted to work out or find a relationship between my x, my y, and my r, remember this distance here would be where we read off the y coordinate, and this distance here would be where we read off the x coordinate. So that would be in the right angle triangle there, x squared plus y squared would give you r squared. So x, y, and r are related by Pythagoras' theorem. So if we have two of them, we can work out the third thing by using Pythagoras' theorem. Okay, remember yesterday we also said that this was 0 degrees, 90, 180, 270, and 360. And when we work out a trig angle, we go anti-clockwise from the positive x-axis. And this r we call the terminal arm. All right, so we're going to use these diagrams to help us solve some problems today. And again, it's trig without a calculator. So we're going to have a question like this. Cos theta is 4 over 5 and theta lies between 0 and 90. Calculate without a calculator and with the aid of a diagram. The value of tan squared theta. Okay, so when you see these kind of questions, when they talk about a diagram and without a calculator, we can see that it hasn't got anything to do with special angles, so it's about trig on the Cartesian plane. When you can see here, they're telling you we're working on the Cartesian plane. Okay, so the first thing we do, use the information given to draw a diagram. In other words, where is the terminal arm? Going to be? Okay, so let's just look. All right, so cos here is 4 over 5. So that helps us by showing this 4 over 5 is positive. All right, and that's what we were doing yesterday. If we look at our cos diagram, where is cos positive? And cos is positive in quadrant 4, and they're all positive in quadrant 1. So I could be working in either quadrant 1 or 4. But what else have they told me? Because I can't work in two quadrants. They've told me that theta has to lie between 0 and 90, which means that it has to be in quadrant 1, because that's from 0 to 90. So we can see here, this is where the two pieces of information lap. So my terminal arm is in quadrant 1. Okay, so you're kind of doing what you were doing yesterday. Okay, so now that I've decided where my terminal arm is, I actually draw a diagram. All right, so here's my little Cartesian plane. Where am I putting my terminal arm? In quadrant 1. And a terminal arm, remember, always starts at the origin and goes out like that. So there's my angle. Okay, now I've got to decide what information I have in terms of x, y, and r. All right, so we go back, and it says a cos is 4 over 5, and cos is x over r, cos x raised. So that tells me that my x has to be 4, and my r has to be 5. All right, so here we go. X is 4. We don't know what y is, and my r is 5. Okay, if you want to, we can make ourselves a little right angle triangle there. All right, and then we need to go off and we need to find out what y is. So we use Pythagoras to find the missing, I'm just going to put side. Okay, so you'll have two of them. Let me just redraw this here. Okay, so my x, this is my x, remember, is 4. This is my y. And we said just now that the relationship between x squared and y squared and r squared is Pythagoras. Okay, so y squared is going to be r squared minus x squared. So y squared is going to be 5 squared minus 4 squared. And I'm pretty sure you guys know that it would be a 3, 4, 5 triangle using a Pythagorean triple. But if not, y squared is 9. So y is going to be plus or minus 3. Okay, remember when we square root? We get a plus or minus 3. We're square rooting both sides there. Okay, now x and y we showed yesterday can be positive and negative. R is always positive. So I've got to check. I'm working in quadrant 1 here. Y is positive. Okay, if you're working in another quadrant, your y could be negative. So you need to double check whether your y in the quadrant that you're working in is positive or negative. All right, so what do I know? I know that x is equal to 4, y is equal to 3 in the first quadrant, positive 3, and r I know is a 5. All right, now I actually only answer the question. in terms of find the value of the other thing. Okay, so the question was, and I actually can't remember, find the value of tan squared. Okay, so only now do we actually go back to find the value of tan squared theta. Okay, so tan is going to be tan your exterior. So it's y over x squared. Remember, the square belongs on the outside of the bracket there. All right, y, we can see here, y was 3, x was 4. No calculator, so we square the top and square the bottom. 9 over 16. And that's the answer to that question. So all the work you did up to number 4 was to help you enable to substitute into your trig ratio. All right, let's try another one, number 2. Okay, so 13 sine theta is equal to -5. Theta lies between 90 and 270. Find without a calculator. And with the diagram. Cos theta plus sine theta. Okay, so again, we're not going to actually answer this find the value of cos plus sine until we've got our diagram, our x, y, and r, and we've worked out where our terminal arm is. So step 1, we got to work out where the terminal arm is. Okay, now I can't work out my terminal arm from this. I need to get my trig ratio alone. So with this one, we've even got more work to do. We've got to isolate the trig ratio so you can read it off as a ratio. So sine theta, remember we're going to divide both sides by 13, so it's going to be -5 over 13. Okay, so here we can see sine is negative. All right, so let's, because there's a -5 over 13. So let's look here. Here's our little diagram. Where is sine negative? Okay, so all ratios are positive here. Sine is positive here, which means that sine is negative in quadrants 3 and quadrant 4. Okay, I can't draw into 2 quadrants. So my other piece of information, theta has to lie between 90 and 270, which means it's got to lie in quadrant 2. So this will be quadrant 2 or 3. See how that would be from 90 to 180. Okay, so where do those two pieces of information overlap? Here, in quadrant 3. That is where sine is negative and it is in the 90 to 270 piece. So where, like yesterday, where does your information overlap each other? So I'm working in the 3rd quadrant. So we go off and we draw ourselves a nice angle. Now remember, you start here, so this is the angle we're dealing with, and we've got x, y, and r. All right, so I need to fill in what is x, what is y, what is r. So let's take step 2, sorry. We know that sine theta is -5 over 13. Sine, save your rear, so it's y over r. Okay, obviously the r can never be negative, so make sure that when you take your r, it's a positive. So this negative must belong to the y. So y is negative 5, r is 13, and I now need to find my x. Okay, so x is the one that's missing here. So we use Pythagoras to find the missing side. All right, so x squared plus y squared is equal to r squared. All right, what am I looking for? X squared. So x squared is going to be y squared minus r squared. It's going to come up here. Okay, so x squared is going to be 13 squared minus negative 5 squared. Please make sure you substitute in brackets. Sorry, here I should have written Pythagoras. I'm going to write it here. It should have been at the beginning. Okay, again, this is one of your Pythagorean triples, but if you don't know that, you would square everything, subtract them. Now we're going to square root both sides. And remember, x and y can be positive or negative, so we've got to check which one do we need. Okay, so in the third quadrant, is x positive or is x negative? Well, look here, my x is going to be negative. So that means I have to choose the negative 12 for the x, because I'm working in a quadrant where x should be negative. Okay, so that tells me that in my diagram, x would be the negative 12, y was given as negative 5, and r is 13. Okay. All right, so what was the question? The question was find the value of cos theta plus sine theta, cos x rays, save your rear. All right, so we just use these pieces of information that we found, negative 12 over 13 plus negative 5 over 13. All right, we've got the common denominator already. Positive times a negative gives me a negative, so the answer to this one is negative 17 over 13. Okay, so this is number 3. This one we're going to be using surd form because we're going to be working with the root 3, but same kind of question. So tan theta, so where am I working? Okay, so tan is negative. Which means I must be working in either all positive here, so that doesn't help me because tan's positive there. Sine is positive there, which means that tan is negative there, tan's positive there, and tan is positive there. So it could be in quadrant 2 or 4. Okay, I need another piece of information. Here's my other piece of information. Cos is smaller than 0, so it's negative. So which quadrants is cos negative in? And if we look, all ratios positive there, sine positive there, which means that cos is also going to be negative. So it could be in quadrant 2 or in quadrant 3. Where are they overlapping? Quadrant 2. So that is where my terminal arm is. Okay, so then we go back and we draw a diagram. From the origin out, remember it comes around this way, so there's my angle into quadrant 2, 1, 2, 3, 4. This is quadrant 2 that I'm working in. All right, and then I need my x, my y, and my r. So let's check. Tan is negative root 3 over 3, and tan is y over x. which means that y is this one and x is this one. Now just be careful with your signs here. Okay, in the second quadrant, y has to have a positive coordinate. These are positive y's, which means that actually this negative belongs to the x. So because with a fraction we normally write it in the numerator, you've got to be careful to see with your x and your y which one should have the negative, numerator or denominator. And in this case it used to be the denominator. So this is -3 for x and √3 for y. So you've just got to be careful. Let's look here. X is negative, y is positive. Okay. So now, what are we missing? Our radius, our r. Okay, we've got our x and we've got our y. We need our r. So we use Pythagoras. X squared plus y squared is going to be r squared. -3 pi plus √3. Please use your brackets when you substitute. Okay, so that's going to be 9 plus 3. So r squared is going to be 12. And then I'm going to square root both sides. And for r is always positive. So I don't worry about a positive and negative. It has to be the square root of 12. Okay, so now I've got my x. I've got my y. And I have my r. So now I can go and answer the question. Okay, let me go back and see what the question was. As cos squared plus sine squared. What is the value of that? All right, so cos x raised, and remember the square goes on the outside, tans your x, save your rear, so sine is y over r. All right, so we said just now x was -3, y was square root 3, and r was square root of 12. Okay, so we're going to substitute. So my x is -3, my r is square root 12. This is going to be √3 over √12 squared. Okay, so we do our powers first. Square the top, +9. Square root of 12 squared is 12. Square the top, square root of 3 squared is 3. Square root of 12 squared is 12. Okay, you have the common denominator here already. So we're going to end up with 12 over 12, which is equal to 1.